Welcome back, students. This is the session 5 from the playlist of IIT JEE Advanced Part 1. The question for this session is written on this board, and this question was asked in the advanced paper in the year 2014. The question here is to find the distance d over which a signal can be clearly seen in the foggy condition. The railway engineer finds that the distance d depends on the mass density rho of the fog, intensity I of the light from the signal, and its frequency f. The engineer finds that d is proportional to I to the power 1 by n, so we have to find the value of n. So here we have been given 4 options, that is n can be either 1, 2, 3 or 4. So here in this question, the distance d depends on the distance d. It depends on the mass density rho. So I am just writing that d is proportional to mass density rho, and I will be writing this equation so that this equation is homogeneous and dimensionally correct. So for that purpose, I will be raising this density to some power. Let's say it is x. Then this distance d is also depending on intensity of the light. So this is I, and this will be raised to some power y, and frequency f. So this will be raised to, let's say, to some power z. Now this equation can now be written as d is equal to, let's us say, k is a dimension that's constant, rho x I to the power y and f to the power z. So now as per the principle of homogeneity, an equation is homogeneous and correct if the dimension of all the terms on the left hand side and the right hand side of the equations are the same. So here we will be finding the dimensions of each and every term. So the dimension of d is L. The dimension of this density, mass density, so density, this is equal to mass upon volume. The dimension of this mass is m upon volume, so this is equal to L minus 3. So this is the dimension of this mass density, and intensity I. Now intensity I is equal to power divided by area. Now power is equal to work done. It is equal to work done upon time, and this will be equal to into area. Now the dimension of I will be, therefore, now work done is equal to force. Work done is equal to force into this displacement divided by time into area. Now force is equal to mass into acceleration into this displacement divided by time into area. So the dimension of I will be equal to, now the dimension of mass is m, the dimension of acceleration is equal to L t minus 2, the dimension of displacement is L, the dimension of t is t, and the dimension of time is t, and the dimension of area will be L square. So from here I will be able to find the dimension of this intensity. So the dimension of the intensity will be now here, this will be equal to m to the power 1. Now from here you can see that this is L square and this is L square, this will get cancelled out, this will get cancelled out, or we can say here that L to the power, we can write it as L to the power 0, and this will be equal to T to the power minus 3. So the dimension of the intensity of light is equal to m to the power 1 L to the power 0 and T to the power minus 3. And the frequency F, the frequency is equal to 1 upon T. So the dimension of frequency will be equal to T to the power minus 1. So now I will be using the principle of homogeneity now. So the dimension of this D is L, this is to the power 1, and this will be equal to, the dimension of this mass density is equal to m L cube, so this will be m L minus 3 to the power x. The dimension of I is m to the power 1, L to the power 0, T to the power minus 3 to the power y, and the dimension of this frequency is T to the power minus 1 to the power z. So from this equation I am getting L to the power 1, this is equal to m, this is to the power x, here this is m to the power y, so this can be written as m to the power x plus y. L is minus 3x, this is 0, so this is L will be equal to minus 3x, and the next one is T. Now T is minus, so 3y and minus z. T is equal to minus 3y minus z. ठीक है, m x plus y, m is x plus y, and L is equal to minus 3x, and T will be equal to the T to the power minus 3y minus z. So what I will be doing here is, now here the dimension of this L is 1, so here the dimension of L is minus 3x, so minus 3x will be equal to 1. First thing, the dimension of m here is x plus y, then here the dimension on the left hand side is, here we can write this equation as m to the power 0, T to the power 0. So this can, so the dimension on the left hand side can also be written as m to the power 0, T to the power 0. So here x plus y will be equal to 0, and T, the dimension of T here is 0, so this will be equal to minus 3y minus z, this is equal to 0. So we have got these three equations, and now we have to solve these three equations in order to get the value of x, y and z. So from this one we have got the value of x is equal to minus 1 by 3, so it implies that x plus y is equal to 0, so y is equal to 1 by 3. And if y is equal to 1 by 3, so if I put this value in this equation, so I will be getting minus 3 into 1 by 3 minus z, this is equal to 0, or minus z is equal to 1, or z will be equal to minus 1. So finally I am getting the equation as D is equal to K, K is a dimensionless constant, rho is to the power x. Now x is equal to 1 by 3, so x is equal to rho to the 1 by 3. Okay, so this is minus 1 by 3, not it is minus 1 by 3, and here I is to the power y, so y is equal to 1 by 3, and f is z. Now z is minus 1. So from this equation we can see that that D is proportional to the engineer has found that D is proportional to I to the power 1 by n. So here from this relation we can find that D is proportional to I 1 by 3, or we can say that n is equal to 3. ठीक है, so n की वैल्यू आ गई यहाँ पर 3 है, so the correct option is C, that is 3. So in this question, the most important thing was that we have to find the, first of all, we have to make one equation based on this question, that is here the this distance d is depending on mass density or the fog intensity of the light and the frequency and the frequency f. So what I have done is, you have to write that that d is proportional to this mass density I and f, and it has to be raised to some unknown power, because we have to make an equation which is homogeneous and dimensionally correct. So from this equation I have got this equation, that is d is equal to k rho to the power x, I to the power y, and f to the power z. And then we have equated the dimension on both the sides of the equation, and by equating the dimension on both the sides of the equation, we were able to find the value of d as k rho to the power k into rho to the power 1 by 3, I to the power 1 by 3, and f to the power minus 1. And since d is proportional to I to the power 1 by 3, so n will be equal to 3. So thank you very much for joining this session. In the next session, I will be again coming up with a different type of a question which has been asked in the advanced paper in the past years, and the chapter will remain the same, that is the units and measurement. So till then, have a nice day. Bye.